All right, Math 8 students, here we are, lesson 4.2, version 2. I actually have the sound working this time, so here we go again. We are in lesson 4.2, determining slope and y-intercept. And so this is not entirely different than what we have been doing. The only thing that we're adding on in module 4 is the y-intercept, which is our non-proportional component of the equations. But before we do that, let's just take a quick review here on what slope is and how we find it. So slope, we use the letter M to represent. M stands for slope, and it is our rise, which is our up and down values, over our run, which is our horizontal, so our vertical change over our horizontal change. Now in a graph, this is all you need to think about. How am I going up or down, and how far am I going over? If you've got actual numerical values, you can think about this is the change in y values over change in x values and you'll also see that written with this symbol here, that triangle which represents change, so change in y over change in x. And remember that slope is rate of change. So whether it's asking you to find slope or whether it's asking you to find rate of change, you find them the same way. You're finding your change in y over change in x, your change in y values over your change in x values. So they are the same thing. And if we think back to module 3, we also know that k equals m, which is our constant of proportionality, which is equal to slope, which is equal to rate of change. And that's just a quick review there for slope. So now we're going to go ahead and move into determining slope and y-intercept with an equation. And so what we're looking at in this lesson is we are breaking this down into determining slope and y-intercept from an equation, from a graph, from tables, and from real-world situations. So by the end of this lesson, hopefully you'll have that introductory knowledge for being able to determine slope and y-intercept from those 4 scenarios. So looking at equations, we want to first remember the difference between linear proportional relationships and linear non-proportional relationships. So remember that the word linear itself has the word line in it. So linear equations are equations that have a straight line. They're a straight line and they have a constant rate of change. And so that just means that we're graphing straight lines. And same thing here, linear non-proportional relationships still have that term line in them. And so they are also straight lines that have a constant, which indicate a constant rate of change. Or slope, right? Because rate of change is slope. So the difference here between linear proportional relationships and linear non-proportional relationships is that what we were doing in module 3 were linear proportional relationships, and that means that they went through the origin. So they started at 0, 0, or they went through 0, 0, right? Origin. And what we are starting to do in this lesson, this module, 4.1 and 4.2, is linear non-proportional relationships, indicating that they do not go through the origin. So they do not start or cross the origin. And there's the bell. And the origin is 0, 0. And remember, this is x and y values. And that's how we write ordered pairs, right? Okay, so if we take and look at equations to try and determine slope and y-intercept, we can look at our slope form. So this is what we were doing in module 3. Again, this is our review, where we have y equals mx. We also started this with y equals kx, just for a little bit review. K and m are the same thing. And m represents what? In y equals mx, m represents slope, right, which is our rate of change. So if you are given an equation and we talked about this a little bit yesterday, like for this here, for this equation here, where y equals negative 4x, this is telling us that our slope from this equation is negative 4, right? So m equals negative 4, which is the same as negative 4 over 1, meaning we go down 4 and over 1. So we're just going to check that here. I found a point here, and I am traveling down 4 and over 1. So negative 4 over 1. So my slope is negative 4 over 1. Okay? And this is a proportional relationship because it crosses the origin. It goes through the point 0, 0. When x is 0, y is 0. So this is a proportional linear relationship. The equation is y equals mx, and you find the slope by taking a look at that equation. Where would m be? That's our slope. So what we are doing in this module is we are looking at non-proportional relationships. So we're adding something special onto our equation. This is called slope-intercept form, right? This is a new equation. And slope is still there, so it's slope as m still. That hasn't changed. This is still slope, or rate of change. But what has changed is that we have added b onto here. So it's y equals mx plus b. And b represents our y-intercept. Right? So, and what that means, if you remember that, if you can recall yesterday's lesson, that is where our line crosses the y-axis. So if I'm looking at this graphic of an example of a non-proportional relationship here, it's linear, it makes a straight line, but it is not proportional because it does not cross the origin. Instead, it crosses at positive 2. So if I was to look at an equation for this line, it would look like y equals 4, sorry, not 4, get my slope right, y equals 1, 4 over 4x plus 2. And I know that because my slope here is up 1 over 4 to my next point between my points of intersection. Up 1 over 4, up 1 over 4. So that's my slope. And so if I was given this equation, this is my m value. That's my slope. And my intercept is going to be this value in my equation, which represents this point right here. When x is 0, y is 2. So my y-intercept, or b, is 2. And so that's how you would pull that information from an equation. You'd look at the format y equals mx plus b, or y equals mx, right? And pull your m and pull your b from that equation. Okay, so let's go ahead and see if we can determine slope and y-intercept from a graph, which we kind of just did up there, but now we're going to look at just the graphs, and we're going to determine our slope, determine our y-intercept, and create an equation, which is what we did up here, but we also were introducing the idea of equations up there. Okay, so take a look at this first one and find the slope and y-intercept. So remember that slope is rise over run. Excuse me, guys. Sorry about that. So slope is our rise over run. And so we're going to travel along this line here, and we're going to find points where there's a clear intersection with a x and y value. There's the bell again. And you don't need to do all these points. What you really need to find is, we know it's a linear relationship, so its rate of change is constant. So you really just need to find 2 good points that are clearly intersecting at x and y values. So I'm going to find my rise, and this is a positive slope because if I read from left to right, it's traveling up. So from this point to the next point, I am going up 2. I'm going from 3 to 1, so I'm going up 2, and I am going over 1, going from negative 3 to negative 2. So my rise is 2, and my run is 1. Rise is a positive 2, run is a positive 1, so my slope is 2 over 1, or simply 2. And then I'm going to go ahead and try and find my y-intercept. So what I'm going to do for that is I'm going to travel along this line and find where it crosses my y-axis. Okay, and so I'm going to look at that here. Looks like it crosses my y-axis here, and that value is x is 0, y is 3. So that means that when x is 0, y is 3, 3 is my y-intercept. So what? I'm sorry, guys. It's cold. It's got me coughing. So y-intercept is 3. Slope is 2. I can now construct an equation in my slope-intercept form. Y equals mx plus b. My slope is 2, so I'm going to plug that in where m is. And my y-intercept is 3, and I'm going to plug that in where b is. And then I'm just going to fill in the rest of my equation around that. So y equals 2x plus 3. If the color bothers you, we'll write it out like this. Y equals 2x plus 3. So what I want you to do now is I want you to try and find the slope and y-intercept and the equation of this graph number 2. So pause the video, try it on your own, then when you think you've got it, play the video, and we'll work through it together. Okay, so hopefully you have tried to work through this graph and find the slope and y-intercept. So what we're going to do to find the slope is find our rise over run, which is our vertical change over our horizontal change. And so I'm going to travel along this line and find points that have clear intersections with x and y values. And I'm going to count my rise and run. So from here to here, this is a negative slope, because if I read from left to right, I'm going down to the right. And to travel from one point to the next, I am traveling down. And I am traveling down how many units? Going from 4 to 2, so I'm traveling down 2 units down and 3 units over. So my rise is negative 2 over 3. And I can't simplify that anymore. That's how we're going to leave that. And we want to leave slope in fraction form, because if we converted this to a decimal, this would be, 0.6 repeating, which you would look at and be like, I don't know how to graph that. So we leave it in fraction form. And then we're going to go ahead and find our y-intercept, which is our b. So that's when x is 0, what is y? So we're traveling along that line and finding where it crosses that y-axis, which is this point right here. So when x is 0, y is 2. So our y-intercept is 2. Then we're just going to plug that into that slope-intercept form. Y equals mx plus b, where m is our slope and b is our y-intercept. We're going to plug in our slope of negative 2 over 3 and plug in our y-intercept of positive 2, and then just put in the rest of the equation around it. For those of you who the color bothers, I'll just rewrite this. Y equals negative 2 over 3x plus 2 with our slope and our y-intercept and our total equation. So now we're going to go ahead and look at how we determine slope and y-intercept from tables. So if you want to take a little break here, I know this is a little bit longer video, but we are covering a lot of information, and it does have a lot of review in it as well. So we've got 2 tables here, and I'm going to do one, and then I want you to do the other one on your own. Remember, I'm just going to rewrite our slope-intercept form equation, which is y equals mx plus b. And I'm just doing that because we're on a new sheet of paper. M is our slope. B is our y-intercept, or rate of change, right? Sorry, it's going off the page there. And then we're going to go over here to our table, and we're going to look at how do we find our slope, m, and how do we find our y-intercept. But let's start with slope. So remember that slope is your change in y over change in x. Notice that slope is set up the opposite of tables. So that's a very common error, to keep your x values on top when it should be your y values. and keep your y values on bottom when it should be your x values. So just keep that in mind. So we know that this is a linear relationship because it says a line. So this should have a constant rate of change. So I'm going to find the difference in y values here. And I'm just going to pick these two. And I'm going to go 32 minus 22 equals 10. That's my difference in y values. And then I'm going to find my difference in x values, my change in x, which is 4 minus 2, and make sure that these are matching. So they're matching here. And that's 2. So I've got 10 over 2 for a slope, or rate of change, and I'm going to simplify that. 10 over 2 simplifies to 5 over 1, which simplifies to just 5. So my slope is 5. Is there another way to do this? Yeah, there is another way to do this. I could notice that there is a constant rate of change here, and that I have constant ratios. I could say, okay, well, from 22 to 23, that's plus 10. From 32 to 42, that's plus 10. From 42 to 52, that's plus 10. And so these should all also match, have the same corresponding values on top, right? So from 2 to 4 is plus 2. From 4 to 6 is plus 2. And from 6 to 8 is plus 2. So these all have a common ratio, a common constant of proportionality. And this helps us because it allows us to find our b value, or our y-intercept. Because what we're looking for is when x is 0, what is y? And so when you have a table, you can work backwards. So if I plus 2 going this direction, I minus 2 going this direction, and that gets me to 0. And that's nice and straightforward. It won't always be that easy, but that's nice and straightforward. So minus 2 to get to 0. If I'm plussing 2 on the top and plussing 10 on the bottom, if I'm minusing 2 on the top, then I'm going to minus 10 on the bottom. So 22 minus 10 is 12. So when x is 0, y is 12. So that would be the point on the graph. And I just have to write this value right here because it's my y value when x is 0. So b equals 12. And then just for extra practice, we're going to make an equation out of this. In our slope-intercept form, y equals mx plus b. Our slope is 5. Our y-intercept is 12. So our equation is y equals 5x plus 12. Cool, huh? If the color bothers you, there it is, rewritten. So the equation for that table is 5x plus 12. It tells us our slope and our y-intercept. So go ahead and pause the video now. Well, after I tell you what to do. I want you to try this second table on your own. So pause the video, find slope, find y-intercept, find m, find b, write the equation, and then press play to check your answers. And remember, if you can always fast forward to see if you got the right answer. You don't have to play it if you know it. Let's go ahead and pause that and work through it now. Okay, so hopefully you paused the video and you've worked through finding slope. So that's what we're going to do now, is find the slope, which remember is our change in y over change in x. And I'm going to just pick these two values here. I know it's a line, so I know it's going to have a constant rate of change. So I can pick any two values. And I've got 15 minus 8, my y values, over corresponding x values, 2 minus 1. 15 minus 8 is 7. 2 minus 1 is 1. So because I know it's a linear relationship, it has a constant rate of change. This is our slope, which just simplifies to 7. So m equals 7. And you could have done what we did over here, where we looked at the change in the ratios. And so this would be plus 7. 7 to 22 is plus 7. 22 to 29 is plus 7. So, okay, my change in y is 7. For my change in, oh, there's another bell. For my change in x, which is from 1 to 2, that's plus 1. From 2 to 3, plus 1. From 3 to 4, plus 1. So here I can see that my change in y is 7, and my change in x is 1, which simplifies to 7. And this is helpful for when I need to find my y-intercept. okay? Because I'm going to work backwards to when x is 0, what is y? Well, I need to get from 1 to 0, I'm going to minus 1, which is convenient because that's what my change is here. And if I'm adding 1, I'm adding 7. So if I'm subtracting 1, I'm subtracting 7. So 8 minus 7 is 1. So when x is 0, y is 1, which means my slope-intercept is this value right here, is 1. So b equals 1. So just plugging that into our equation, y equals mx plus b, where m is the slope, b is the y-intercept. Plug in my slope of 7. Plug in my y-intercept of 1. Just build my equation around that, and I've got y equals a slope of 7x plus 1. So y equals 7x plus 1. That's our equation for the table with our slope and our y-intercept. All right, guys, hang in there. I know this is a long one. We're on our last scenario here, and that is determining slope and y-intercept from a real-world situation, which we have traditionally called word problems. And so this is actually real-world applicable. This is a valuable tool and a valuable formula because we all want to know how much money we're making over time. Or if we look at cell phone plans, do we have an initial cost no matter how many minutes we use? All that kind of stuff. So before we get started reading we're going to go ahead and start with this. So Greg deposits the money he makes from mowing lawns into his savings account, adding it to the money his father already gave him to open the account. So we've got two values here. We've got money he makes mowing lawns, and we've got money his father gave him to open the account. We want to confirm that the relationship is linear, so it has a constant rate of change, and give the constant rate of change and the initial value. So we want to determine that it's linear with a constant rate of change, right? Because if it is linear, it has a constant rate of change, and determine the initial value. So I color-coded those for a reason, because we're going to use our slope-intercept form equation. Y equals mx plus b. Are you sick of it yet? Don't be, because we're going to use it a lot, where m is our slope, or rate of change. So anything that I've underlined in here has to do with our rate of change, right? And in this case, that represents the money from mowing lawns. Because that's the value that's changing. That's how this is what's being added into the account on a regular interval. Whereas B represents our y-intercept, but also represents our initial value. In this case, that's the money his dad gave him to open the account. So that's a value that's already in the account when he starts adding money to the account from mowing lawns. So he starts with this money. He adds X amount of money per lawn, and he ends up with his total amount. So X represents our independent variables, which is our number of lawns mowed. And Y represents our dependent variable, represents his total money in this bank account. Because that there is going to depend on how many lawns he mows, right? So this is our dependent variable because it depends on the number of lawns. So let's get started. We've got a nice table here, so we're going to go ahead and try and find the rate of change. And so we can find our change in Y values, right? Which here 10 minus 5 would be a plus 5. 15 minus 10 is a plus 5. And 20 minus 15 is a plus 5. So for this to be a constant rate of change, each of these should have a matching value for their change in Y's, right? So from 110 to 170, I would do 170 minus 110, which is 60. It should be, hopefully be a 60 here again if it's going to be a constant rate of change. That's 60. And here again, this is also 60. So it has a constant rate of change. So our change in x and our change in y, remember this is opposite of slope, so I'm going to have to flip it for slope, right? Our change in y is 60. Our change in x is 5. Can we simplify that? So m equals 60 over 5, because remember I had to flip those. And that gives me 60 divided by 5 is 12 over 1. So this is saying that if this is the money and this is lawns, right, because x is lawns and y is total amount, that he makes $12 per lawn. So he makes $12 per lawn. That's our rate of change there. So we found our rate of change. We know it's constant, so it will make a line. And now we need to find the initial value. So remember what I'm going to do is I'm going to work backwards to 0. So I'm going to try and get to 0 for my x and find out what my y is. Well, it's nice and convenient here. All these tables are super nice. To go from 5 to 0, I'm going to minus 5, which is awesome because I've already got that ratio here. And so if I'm minusing 5 on top, what I'm doing on the bottom is minusing 60 because that matches what we've done. That matches this rate of change here. So 110 minus 60 is 50. So when my x value is 0, my y value is 50, which means b equals 50. And remember that b represents our initial value, so that what his bank account started with, which is the amount of money that he started with from his dad. So, and we should also make sure we're using our units here. So b equals $50. So he started with $50 from his dad. He makes $12 per lawn. And just for good measure, we're going to go ahead and create an equation to show that we're understanding this. Y equals mx plus b. Rate of change, initial value. And what this equation does is it lets us know how much he makes by plugging in any number of lawns. So my rate of change is $12 per lawn. So I can just put 12 here. And the initial value, the amount of money he started with, is 50. So what I've got is y equals 12x plus 50. So if he mows 6 lawns, I would plug that in here. 6 times 12 plus 50 will give him the total amount he has in his bank account. If he mowed 100 lawns, 12 times 100 plus 50 gives him his total amount of money in his account. So we got m, we got b, we know it's constant because we have a constant rate of change, and we also, for bonus, found our equation. All right, folks, I know that was a long one, and you hung in there. So I will see you in math class. If you got questions, remember to write them down, ask them. I'm here to help. And you will be working on lesson 4.2 in class tomorrow. This is lesson 4.2, determining slope and Y-intercept.